I'm very pleased to be making this video to highlight the benefits of the numeracy map and the alphabet map. I have the teacher versions here and I've also got the pupil versions here. They stem from my research into dyscalculia, where the importance of the numeracy map became abundantly clear the more I worked with children who are dyscalculic. There is this concept called a dyslexia-friendly classroom, which is beneficial for all learners. I'm convinced there is the potential for a dyscalculic-friendly classroom, which will also be beneficial for all learners. And the numeracy map has an important role to play in that. Okay, so let's start to see how the numeracy map can help with our numeracy skills. I have both a pupil version and a teacher class size version. I'll use this for the video. So let's do some sums, like 6 add 3. 6 on the numeracy map lives here, and to add on 3, you move on 3 and you arrive at 9. So it's very visual for younger pupils to see how to add and subtract. Of course, if it was 26, add 3. 26 lives here, and we add on 3 and we come to 29. So younger children really enjoy the fact that these are visual, concrete approaches. Of course, it can get into harder sums, like say 46, add 29. 46 lives here, and when they have more of the numeracy map in their heads, they realise that 29 is nearly 30, and they can take shortcuts to add on 30. 46 add 30 would be 76, but because it's only 29, it should be one less, and the answer will be 75. So the numeracy map is very powerful at helping to explain addition, as it is also for explaining how to do subtraction. So for instance, 10 take away 4. 10 lives here, and to take away 4, we go the opposite direction, take 1, take 2, take 3, take 4, and we arrive at 6. And of course, if it wasn't 10 take 4, but 70 take 4, 70 lives here. Take 4 is the same journey, going to the left, take 1, take 2, take 3, take 4, and we come to 66. Then the teacher's in a position to show why 70 take 4, when we use the algorithm, and we'll have to exchange. 10 take 4 is 6, and there's a 6 here. The algorithm has to agree with the answer the map gave. So we can also do quite complicated subtractions with the numeracy map. Things like, for instance, 75 take away 39. A kind of sum that a lot of children would struggle with. But if they have the numeracy map in their head, it's much easier. So we have 75. 39 is nearly 40, so take 10, take 20, take 30, take 40. That was too much, but it's only 39, so we have to put 1 back on. So I think the answer should be 36. Then the teacher can show the algorithm, 75 take 39. With all the exchanging, 5 take 9, can't do. We exchange from the 7, makes it a 6, and this becomes 15. 15 take 9 is 6, and 6 take 3 is 3. 36. My work with dyscalculic pupils, or children, or young adults, suggests that the numeracy map is hugely powerful for their learning of number. It really helps them understand number. It is also very good for multiplying. I could do any of the tables on this map. I'm going to choose to do the 4 times table. The 4 times table starts at 4. And if you just simply add on 4 the whole time, we will make a picture of the 4 times table. So 4 add 4 is 8. Add another 4, we come to 12. Add another 4, we come to 16. And add another 4, we come to 20. So far, I've added 4, add 4, add 4, add 4, add 4. 5 4s are 20. I'm going to keep going to a very special point on the map. If you keep repeated addition of adding on 4, and we do it correctly, we should land on 40. The 4 times table starts at 4, and it has to land on 40. Now I'm in a position to do multiply sums. For instance, 6 4s. 6 4s is quite simple. 1, 2, 3, 4, 5, 6. 6 4s are 24. We can also do divide sums for the 4 times table. For instance, if it was 32 divided by 4, 32 lives here, and 4 fits into 32 1, 2, 3, 4, 5, 6, 7, 8 times. The answer must be 8. Young children who struggle with division find the numeracy map very, very powerful. Let's do one more table. I'm going to choose the 8 times table. 8 times table starts at 8. And if you add on 8 the whole time, we'll make a picture of the 8 times table. 8 is nearly 10, so it'll be 2 less each time. Here's the pattern for adding on 8, starting at 8 and adding on 8. If we do it correctly, we should get this lovely pattern here. There is a picture of the 8 times table. So I can now do sums like 3 8s. 3 8s are 24. Or I could also do 3 80s, 240. I can also use this picture to do divide sums with 8. For instance, 48 divided by 8. 48 lives here. 8 fits into 48 1, 2, 3, 4, 5, 6 times. The answer is 6. Of course, if it was 480 divided by 8, the answer would be 60. The numeracy map becomes even more powerful with complicated divides. For instance, say it was 35 divided by 8. Younger children find division with decimal answers very difficult. I'm going to finish this demonstration of the numeracy map by doing this sum on the numeracy map. So here we go. 35 divided by 8. 8 goes into 35. 35 lives here. 8 fits in 1, 2, 3, 4 times, and 3 left over, remainder 3. So it's 4, remainder 3. We need to put a decimal with a 0. It's now 8 into 30. 30 lives here. 8 fits into 30, 1, 2, 3 times, and 6 left over. 3, remainder 6. Put a 0. 8 into 60. 60 lives here. 8 fits into 60, 1, 2, 3, 4, 5, 6, 7 times, and 4 left over. 7, remainder 4. Put a 0. 8 into 40. 40 lives here. 1, 2, 3, 4, 5. The exact answer is 4.375. Notice the 8 times table started at 8 and landed on 80. The numeracy map is very powerful for helping children get better at numeracy. It's as fundamental to numeracy as the alphabet is to literacy. If a child's struggling with number, I would guarantee there are aspects of the numeracy map missing from their repertoire. Well, the mapping techniques that we can use with the numeracy map for addition, subtraction, multiply and divide are equally valid for what I've called the alphabet map. For instance, n or n, n, b, e, r. Number. We found that children quite like the alphabet as a vehicle to map, to write simple words. And the mapping techniques that we can use with the alphabet map are just also fantastic for the numeracy map. There are many games you can play in the numeracy map, and the more of the map you have in your head, the better and better you'll be with your numbers. And when working with the dyscalculic children, one of the most successful activities was maybe a packet of Smarties, and simply just mapping a Smartie on to each of the numbers as a way of counting the Smarties, not just counting them, but actually making a relationship with that physical symbol for 13. There's 13, 14, 15, 16, 17. And we counted out 17 Smarties. After that, we also started to make simple bar charts. I'll show you a simple bar chart from the Smarties. And they found this actually very helpful too. There are many games on the numeracy map we can play, and here's a bar chart with Smarties. It's also a sorting exercise. And then we counted each number of Smarties in a particular colour, and of course when you add them up, it comes to 17. And then of course we eat the Smarties afterwards.